so that others can benefit from your question. Okay, so I'm going to restate your question and I will answer it again. All right.
Okay.
So your question was, what is the difference between a confidence interval and a hypothesis test? All right. And I said a confidence interval is the foundation of hypothesis testing, or the beginning of hypothesis testing. Now, and when we can do a confidence interval, but we can also do a one population hypothesis test or a one sample hypothesis test, and you can do a two sample hypothesis test or a two population hypothesis test. Okay. Now, in a one population hypothesis test, essentially what you're saying, let us say we take the students at Medgar Evers College, and we ask ourselves, what is the average GPA of students who come to Medgar Evers College? And we simply take a sample. And then we say, okay, the average GPA is between 2.1 and 3.3. So that's the range. And you give yourself a 90% confidence or a 99% confidence that this is what the average GPA would be. All right? But your problem here is that you don't know what the average is. And so you want to find out, you want to get an estimate of it. Now, in a hypothesis test, you can now take a one population hypothesis test where you take all the students at Medgar Evers College and test a hypothesis. The hypothesis simply says, I think that the average is about this. And so you already have an idea what you think it is about, what you think the average is. And so you test the hypothesis to say it is about 2.4, approximately. Okay. Now, that's a one population hypothesis test, but you can also break the population of Medgar Evers College students into two. You can say, I want to compare the males to the females. And you say the average GPA of males is equal to the average GPA of females. You can break the students into two separate subpopulations, say transfer students and students who are admitted from their freshman year, or who have been here since their freshman year. You can do that. You can say, you can break the population into two and say, I want to compare those who live in Brooklyn and those who live in the Bronx. You want to compare those who are working while they're going to school and those who are not working while they are going to school. Those, in that way, you are comparing two populations. So that's called a two population hypothesis test. All right? So does that answer your question?
Yeah, kind of. Yeah, it actually did answer my question. It did. I just had another question from the test. I mean, not from the test. I apologize. From the homework.
Okay.
And you will understand why I asked the question is because for the machine homework, after I calculated machine 2 and machine 3, I noticed that the confidence interval overlapped.
Yes.
But when I did the hypothesis test, the one mean hypothesis test, machine 2 did not, I didn't accept the null for machine 2, and machine 3 I did accept it. So I thought my numbers was wrong. That's why I asked.
Okay. We're gonna look through that particular problem, and I'm glad you're bringing it up. We're gonna look through it. So we're gonna walk through it so as to make sure that you are answering the right questions. If the confidence intervals overlap, that means there is really no difference between the two of them in terms of their performance. But it depends on what you are testing. Okay. But then when you were not able to reject the null hypothesis in one, but you rejected the null hypothesis in the other, again, it depends on what you were testing for and how you were doing the test. And then, of course, at the end of this lecture, you can always ask for your assignment to be cleared so that you can resubmit. Understand that?
Yes, okay. Yes. Well, I haven't submitted it yet because I wanted to speak to you first about it before I submitted it.
Okay. So I think we have waited enough. And so let's go through the lecture first, and then we will look at specifically at the problem you're talking about. Okay. So I'm going to pull up the slide. So are you able to see my slide?
Yes.
Okay. It's not going to be a long presentation. So we're going to formally be talking about hypothesis testing. All right. Like I said, the difference between confidence interval and hypothesis test is that in confidence interval, you're just trying to estimate the average. That's what you're trying to say. You say, I don't know what the average is. So let me estimate what it could be. By hypothesis test, you already have an idea what you think the average should be. You're going to now test that hypothesis, whether it is accepted or you want to reject it. Now, but you can also use a confidence interval to actually reach a hypothesis testing conclusion. So, but let's go through the process of hypothesis test. Okay. Now, we're going to define a hypothesis, explain the process, how we do hypothesis test. There is a 6-step procedure for testing a hypothesis. And we're going to try to distinguish between a one-tailed test and a two-tailed test of hypothesis. Okay. Then next week, we're going to conduct the test of hypothesis, but compare a one population hypothesis test and then a two population hypothesis test. I already explained to you what a two population hypothesis means, but we have not gone through one, to actually see how it works. And of course, we're going to interpret the rho value. And then finally, we will use a t-statistic to test a hypothesis. All right. Now, here's an example, as I explained to you earlier, that in a hypothesis test, you already have an idea what it is that you think the average should be. You already have an idea. The average should be so and so and so, okay? For example, a machine is expected to produce 595 units per day. And so what you do here is you take a sample from the available data. I mean, every day you say, how many units did this machine produce? This machine produced 615 today. Another day, you take another sample, it produced 494 on that day. Another day, you take a sample and it produced 585. And then another day, 632. Now, as a production manager, you want this machine to produce 595 per day. And so when you take, say, 100 days, or 40 days, or 50 days, random sample of 50 days, say, you say, during the next 50 days, I'm going to see how much this machine produces. And you could be doing it for a number of reasons. One, you want to ask yourself, is the foreman, are the production guys using this machine, are they doing their job? You could also do it to ask yourself, is this machine functioning properly? If the machine is supposed to produce an average of 595 per day, and it is producing 495 per day, then something is wrong. It's either the machine is not functioning properly, or the people working on the machine are not using it properly, or they're doing something wrong. Or maybe they're just goofing off. Instead of doing their work, they do something else. Or they do not watch the machine so that when something is going wrong, they can fix it so that the machine can function properly. All right? So that's why you are doing something like that, testing a hypothesis. So you take a sample and ask yourself, is this machine doing well? All right. So now the 6 steps are for testing a hypothesis. The first step, I'm going to increase this so that hopefully you can see it properly. Can you see it better now? Hello? Hello?
Yeah, give me a minute. I got it on mute, Professor, but I could hear you better. But yes,
Okay.
I'm here. I could see it. You zoomed into it. I can see it.
Yes. Okay. So the first step is to state the hypothesis. And the way to state the hypothesis is to state what you call the null hypothesis. The average is 595. The alternate is the average is not 595. Or the alternate could be the average is greater than 595. Or you can say the average is less than 595. That is a hypothesis. You have to make a statement. A hypothesis is a statement about the characteristic of a population. Okay? Then you select a level of significance. Okay? You select a level of significance. Now, you can say, I'm going to select a 2.5% level of significance. Okay? You can say a 1% level of significance. Okay? A 2.5% is 0.025. A 1% level is 0.01. Okay, so you select that level of significance, and I'm going to show you exactly what it means. And then you identify the test statistic. Okay. Now, we say we identify the test statistic in the sense that here, for this class, we are using the normal distribution, and the test statistic for the normal distribution is the Z statistic, which we've already talked about. Or you can use the T. The T is for small samples, and the Z is for large samples. Okay, but here we're using the Z. Okay, somewhere along the line we're going to learn how to do the T. Then you formulate a decision rule. You formulate a decision rule. Okay, the decision rule simply says if Z is greater than, if the calculated Z is greater than the critical Z, then we reject a null hypothesis. Then you take a sample. Now, once you take the sample, you calculate the sample mean, which is X bar, and then you can calculate the sample standard deviation, which is S, and then you apply the decision rule, and then interpret the result. Now, like I was saying, you identify the test statistic. As you do more statistical analysis, you find out that there are different test statistics. There is a chi-square test statistic. There's an F distribution test statistic, and there's a whole bunch of others, all right? But for this class, we'll make it simple. We'll use the Z, and somewhere along the line, we'll try the T. And then we're going to use the F, okay? The F statistics, F as in Frank, all right? Okay. We already talked about that. You state the null and alternate, okay? The null hypothesis is stated as H0. The alternate is stated as H1. Sometimes we state it as HA, all right? It could be H1, it could be HA. Whichever one is your preference, that's up to you. All right?
Yes, Professor, I heard you.
All right. Here is an example. All right? A performance example. Now, a production machine is designed to produce 595 units per day. So we then take a sample out of 38 days. It's selected and the output shows a sample mean of 625. So when you select a sample, the question then, you calculate the sample mean first, okay? And we're going to do this, and I'm going to pull up an example from scratch and show you what we mean by the output shows a sample mean of 625. 625 does not come from the sky. It doesn't fall out of the forest. There's a way to get the sample mean, and you know how to calculate sample mean. But I'm going to go through a simple problem, and we'll show how that is done. And then the sample mean also has a sample standard deviation of 65.55. So our problem now is we test the hypothesis at 0.01 level of significance. Let me make that clear. Level of significance. That the machine meets or exceeds the expected output. Okay? And so we're going to ask ourselves, when we test a hypothesis, we're going to test if mu is actually equal to 595 or more than 595. Okay, so let me insert symbol. Okay, so our test hypothesis is to produce at a mean of 595 per day. So that is the population mean. Okay, we're saying the population mean should be 595 per day. But now we take a sample mean S, sample mean S output equals 625. And the sample standard deviation, sorry, this is X bar. Sample mean, sorry. We insert symbol. X bar. So we get X bar equal to 625. And the sample standard deviation of S equals 65.5. So the sample mean is 625 that we calculate, and the sample standard deviation is 65.5. So our objective is to test the hypothesis at 0.01 level of significance that the machine meets or exceeds its expectation. Okay, so now, what will be our hypothesis? Okay. So now, like we said, we collected sample data from 38 days. We calculated the sample mean of 625. That is, sample mean shows 625, and the sample standard deviation of 65.5. Now, like I said, in order to test a hypothesis, you have to state the null hypothesis. So let me see. All right. So before you actually collect data and test your hypothesis, you should really do this first. So let's go back and do first things first. Okay. All right. Okay. You state the null hypothesis that the mean is 595. Like I said, you already have an idea what you think the mean should be. And your whole objective in statistical testing is to test hypothesis. So this is what my feeling is, okay? So after you state the null and the alternate hypothesis, you then collect the data. Collect a data sample. Here we collected 38 samples. So here again, I restate the hypothesis, then I calculate the sample mean 625 and the sample standard deviation 65.5 from sample of 38 units. So now we say the level of significance is 0.01. And from the last time, we showed that for a level of significance of 0.01, the critical Z, and this is what you call the critical Z. The critical Z value is 2.33, okay? Oh, we already defined it, okay? The critical Z value is 2.33, okay? And so now we're going to get the calculated Z value. We're going to calculate the calculated Z value. And the calculated Z value is X bar minus the null hypothesis, and the null hypothesis here is 595, all right, divided by the standard deviation over the square root of n. Here, the standard deviation we calculated as 65.5 divided by the square root of 38. When we do this calculation, we get a value of 2.821, all right? And so the decision rule for us to reject or not reject the null hypothesis is if Z is greater than Z star, we reject the null hypothesis, okay? If the calculated Z is greater than the critical Z, so I'm gonna label this again. So we're gonna call this the calculated Z, okay? So we compare the calculated Z to the critical Z. If the calculated Z is greater than the critical Z, then we reject the null hypothesis. All right? And so in this particular problem, we see that the calculated Z is greater than the critical Z. And therefore, we reject the null hypothesis. What are we rejecting? We are rejecting the hypothesis that mu is exactly 595. And since we are rejecting that mu is 595, we are concluding that mu is greater than 595. This is what is called a one-sided hypothesis because we are simply saying the alternate is that mu is greater than. If it was a two-sided hypothesis, we are simply going to say that mu let's see. We're simply going to say that mu is not equal to, that's it. Okay? If that it is not equal to does not mean that going to ink an equation here. Okay. This will be a two-sided hypothesis. If we say greater than or less than, then it's called a one-sided hypothesis. But this will be a two-sided hypothesis. And therefore, we concluded, like in this particular problem, that the machine produces more than 595 on the average. Okay? Now, like I said, I'm going to illustrate to you how this sample mean comes about. Okay? So give me a minute. Let me get some data. So I'm going to stop that share. I'm going to bring up another share. Okay.
Okay.
All right. So here is data on a machine. And so on some machines, okay? And there are three types of machines here: machine 1, machine 2, and machine 3. So we're going to ask ourselves, let us test a hypothesis about machine 1, just machine 1. All right? Are you seeing my spreadsheet?
Yes, I can see the spreadsheet.
Okay. So this is machine 1. So we're going to take all the data from machine 1. Okay? And we're going to test a hypothesis about machine 1. So I'm going to copy machine 1. I'm going to put it there. All right? And so that sample mean we got, how did we get it? Just come in here and say equals average Okay, so this is the average. So we get an average of 259. Get that? So this is what we call our sample mean.
Yes, I got that.
All right. That's it. There's nothing magical about it. The sample mean is you take a raw data like this, and simply get the average. So the next thing is to get the sample standard deviation. The sample standard deviation. And again, I'm going to say equals stdev s I'm going to take the same data. You calculate the standard deviation, which you can calculate by hand. You want. Okay. You get 584. So this is the sample standard deviation. And then you use it to do the hypothesis test that we talked about. How many?
I'm sorry, Professor. Are these the same numbers as the homework?
Yes, I got it from the homework where you're comparing the two machines.
Okay. All right. My standard deviation, I got the same, but for the average, I got 259, 627.
Well, I got 259, 114.
Yeah, I'll check mine. I'll recheck mine.
You know, I mean, maybe I didn't copy everything. Okay. Okay, I didn't take everything. Okay, so let me get it to 29.
You say you didn't get everything?
Yeah, so now I have 259, 628.
Okay, yes, that's what I got.
Okay, so I missed the last one. I missed the last one when I was calculating the average. Okay, so now you use the sample mean and the sample standard deviation to do the hypothesis test. What was the sample size? I can say it was at count. So I have a sample size of 28, okay? Which is a small sample. But This is what we have. And so we have a sample size of 28, and so you cannot do a test of hypothesis. So the sample mean you saw we got there, I mean, it was given to you, but in a practical situation, you would have to do your own calculation. You have to get your own sample mean, and there is no other way to get it. I mean, it's not a difficult thing to get. Just take an average, and then you calculate the standard deviation. So this is just the illustration of how you get your numbers. They don't come from heaven. They don't come from the forest. They don't come from the sky. They actually, you do your own calculation. So I'm going to stop that share.
But now my question is this, because in the homework, the question says that it specifically says that machine 1 produces 700 units per minute. Machine 2 produces 200 units per minute, and machine 3 produces 155 minutes per unit. So
okay, let's go to the problem. Okay.
Okay.
Let's go to okay. Okay. Are you seeing my screen?
Yes, I can see your screen.
Okay.
So you see where it says it right here? It says, I think the second sentence, it says the rated production rates for machines types 1, 2, and 3 were 700, 200, and 155. So
that's correct.
This is pretty much the average population rate. So what we just
expected.
The expected. So what we just calculated is the sample, and what they given us here is
okay. But you realize also that you were given a problem that essentially demands of you to do some critical thinking. Now we said the average is 700 per unit, so you have to calculate the average for all these machines. What we have here is the total for the day, working at 7.75 hours. So how many minutes are in 7.75 hours? So that means you have here now to calculate per minute output. Okay, per minute.
Yes.
Q. I'm going to call it PMQ.
So you do the decimal times 60 to get the minutes.
So the per minute output will be equal C2 divided by D2 times 60.
Wait, you did what?
Now, I calculated the per minute output because you were given the output for the whole day. I illustrated the hypothesis testing and the calculation of average based on the output for the whole day, not the output per minute. I just wanted to show you how the sample mean and the sample standard deviation are obtained. But for you to solve this problem correctly, you have to calculate the output per minute.
Exactly. But how did you calculate? Because how did you just calculate it?
Let me stop that share. Let me stop that share and bring up what I was doing.
Okay. That's what I was at, because I explained to you how I did it. Or what I did was I ended up getting the average. It gives you the average hours worked, and it also gives you the average hours down. So what I ended up doing, I just
average hours worked. That other information again is one of those critical thinking things we try to get students through, which is
so
for you to know what information is relevant for you and for you to know what information is not relevant.
Exactly. So what I ended up doing, let's say for machine 1, that's the one we're working on now. I took it's 700 units per minute. I took 700, multiply that by 60 because there's 60 minutes in an hour. And
Oh,
then
no, 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 no. That's the wrong thing. What you should do, because it says the machines are supposed to produce, this machine was supposed to produce 700 units per minute. Am I correct?
Yes.
Good.
Yes.
But it says what we're trying to measure is if the machine operates at 85% of its expectation, we think the machine is doing well. And so, are you now seeing my spreadsheet screen?
Yes, I can see your spreadsheet screen.
Okay, so this is per minute output. Okay. Let me call it per minute output, right? PM out. Let's call it per minute output.
And how
So
did
you are supposed to,
calculate?
first of all, calculate the per minute output because you are testing for the per minute output. The output per minute.
How did you calculate the per minute output?
Well, this is the daily output, 320,000, right? If the machine worked 7.75 hours, right? That means you take the daily output divided by 7.75 times 60 because it would have worked 7.75 times 60 minutes.
Yes, yes, that makes sense. Okay.
Okay, so that is C2, which is the daily output, divided by D2 times 60. You see it?
Yeah, C2, yeah, the production rate divided by the hours work times 60, times 60 minutes. Okay.
And so you drag it down. And so for each machine, you get its per minute output. That is the output per minute. So for each kind of machine, each type of machine, you then calculate the average output per minute and the standard deviation of the output per minute.
For each machine?
Yeah, for each machine, yes.
Okay.
This is machine type 1, am I correct?
Yes.
And then we go to machine type 2.
No, you mean for each machine type?
Yeah, for each machine type, yes.
Okay, yes, yes, yeah, I get that.
Okay. So once you calculate the output per minute, then you get the average output per minute, which is the sample mean, and then the standard deviation of the output per minute, which is S, and then you proceed with your hypothesis test.
So can we at least do machine type 1?
Can you do what?
Can we at least complete machine type 1?
Hypothesis test?
Yes.
Okay.
Because you said once you get the per minute per output, you'll get the average for machine type 1, you get the standard deviation for machine type 1. And then
that's easy. So let us take the I'm going to take this out. I'm going to recalculate this, right? This is per minute output. So I'm going to take this for machine type 1. So we have the per minute output. Okay. Two. All right.
okay, so you see the average change there. So the average is 639 now.
That's correct, because it is not per minute. not for the whole day. You get the point?
Yes.
Because what you were measuring initially was the total output for the whole day, for the 7.75 hours.
Okay.
So now we have the per minute output. So I'm going to call this PM output 1. You can do it for 2. You can do it for 3.
Yeah,
You
yeah.
get it?
So then, yes, I do understand that. And then now, when you calculate, because then the next question it asks to test it to see if it's working above 85%. Just looking at it, you could tell it's not, right? Because it's
Well,
saying that.
you haven't tested that yet. You don't do that in statistical analysis. So I'm going to take this, the 639.09, and the sample standard deviation is 60.48. The sample size is 28, which is a small sample size.
You got to get the
So
standard error now, right?
we already have the standard deviation, but that is not the standard error.
Yes, exactly.
Okay. So now let's go back. We have the numbers down. Write them down. I'm going to stop share. And I'm going to pull up these PowerPoint slides again, and I'm going to continue from there. Okay. All right. So we're going to apply this formula to the so I'm going to put it in a new slide. Machine 1 hypothesis. All right. So this is what we're doing. Machine 1 hypothesis. All right. The null hypothesis I'm going to change the null hypothesis. Now, first of all, we said the machine should be operating at 85% of capacity. Am I correct? You there?
Yes, I'm here. You said how much is this? 85%.
Yeah, 85% of capacity. Is that correct?
Yes.
Good. So what is 85% of 700?
85% of 700.
Yes.
I don't know, 85 times. I don't know. I'll tell you right now. $595.
Very good. So that is how we got that 595. That is how we got 595. And so the alternate hypothesis will be that mu is greater than 595. And what were we supposed to test at? We were supposed to test at 0.01. Okay.
Professor, because for specifically machine type 1.
Okay, so you wanna test machine type 2 just to give you a different flavor.
No. We could stay with 1. I'm just saying because because the sample size was 28, we got to do the t-test, right?
And you gotta do the t-test.
Got it. Okay. The degree of freedom 27 when we look in the chart, right?
That's correct.
Okay, got it. So I got 2.771.
2.771. Okay, so level of significance. Critical Z, actually critical T, because it's a small sample, is 2.771. All right. Okay. So we calculate then copying formulas so that we don't have to spend all that time. So we're going to calculate the T. It's equal to that. So we got 639, am I correct? 639.09.
Yeah, 639.09.
Okay, and the standard deviation was 60.48.
The standard deviation, I can't remember what it was.
Yeah, 60.48 and divided by the square root of 28. So what does it give you? Give me the calculation.
Okay, give me a minute. Hold on.
Go ahead, take your time.
3.8575.
3.8575. Okay. Verify. Right. Okay, 3.8575. So you're correct. So now decision rule will then be if T is greater than or equal to T star, reject the null hypothesis. Okay, if T, and here T is 3.8575 is greater than the T star, 2.771. So that means implies we reject the null hypothesis. So in this particular problem, we're rejecting the null hypothesis that mu is 595. And so we are concluding that mu is greater than 595. So this machine is operating, functioning properly. You get the point?
Yes.
So somebody could ask you the question, identify the machines that are functioning properly. So what you would then say, if the machine is functioning properly at 85% of its capacity, so for machine number one, then our null hypothesis will be to test whether the machine is producing 595 or less, or whether the machine is producing more than 595. Right?
Got it.
Okay. So once you test your significance and say the machine is producing more than 595, when you reject that null hypothesis, then your conclusion will be this machine number one is functioning properly. Because somebody could ask you a question. Is the machine functioning properly? Period. So you now have to define what proper functioning is, which is to produce more than 595. Then it's for you to test the hypothesis whether the machine is doing 595 or doing more than 595.
Okay, got it. Now, my next question, that because I was trying to add a confidence interval. That's why I asked you earlier, what's the difference? To formulate the confidence interval, let's say for machine one, how would you do that?
Very good. So let us go to confidence interval. All right?
Okay.
I'm going to pull up the thing about confidence interval and show you how we could have done this same problem using confidence interval. All right? So okay. I'm going to stop share. All right, so I'm going to share. I'm going to share screen again. Okay, it might be the wrong one. All right, so we're going to take the same problem and we're going to use confidence interval to test the same hypothesis, right? Do you get the point?
Yes, I'm here, Professor. I'm listening to you.
Okay, so now you know our T was 2.771, right? And X bar.
Professor, you put 2771 is 2.771.
Yeah, I think it's 2.771. That's
yes.
what we. Okay, so X bar equal to 639.09, right?
And the standard deviation, I think you said was 60 point, let me look it up.
60.48. You're correct?
Yeah.
Very good. Okay, our sample size is 28. You correctly calculated the critical T. So we're just going to apply that formula, all right? So I'm going to copy the formula. Put it down here. So instead of that, I will have 639 639.09, and our T will be 2.771. Our S will be 60.48. Our N will be 28. And here again, $639.9. Our T will be 2.771. Going to reduce the size here to make it easy for us.
Professor, I think the standard deviation wasn't 60/48.
What was it?
I'm not sure. If you could probably check again in the Excel, I think it was something different.
Okay, let's get to that in a minute. It's 60.48.
Okay.
60.48. Okay. And here our S is 60.48 by the square root of 28. Right? And so now you do the arithmetic here. This is the bracket there. This is a bracket there. This is a bracket there. And this is a bracket there. And so
Okay, see, that's where I was confused at, Professor. I wasn't sure we used the 639 or the 700.
no, you use the sample mean because remember that you are testing for 85% of 700.
Okay.
And so when you do that arithmetic, 60.48 over the square root of 28.
It is. Give me a minute.
So what we have is,
Yeah, I'll give it to you right now, Professor. I'm calculating.
okay, 9.09 plus 2.771 times 11.426, 11.26.
I think I got the wrong. Oh wait, hold on. All right, so the calculated Z is 31.67, and I guess you plus and minus 37.67 to
Okay, do you see the
639.
formula I'm putting up on the screen? I calculated this first.
Yes.
Okay, so that's what I
Yes.
calculated first.
Yes,
So
and I got, when you multiply that 2.771 times 11.4296, I got 31.67.
That's correct.
And when you the lower interval is 607.79, and the high interval is 6.71.13.
The 6 what? 671?
The 671.13, and the low one is 607.79.
Very good. Now, how could you do test of hypothesis using this? How could you use this to do a test of hypothesis?
Not sure.
You're not sure? Okay. So what is the confidence interval? You're saying you're saying the confidence interval, the problem is you don't know what the true average is. Am I correct?
Well,
that's what we said. That's what we said. We don't know what the true average is.
Okay, so all right. So what is this? Isn't this, because that's where I was confused at. Isn't 700 a true average of type 1
No,
machine?
no. That is, you are saying that the machine was designed to produce 700 per day.
Okay, got it. I'm
But
thinking
if the
700.
machine does 85% of that 700, we say it is doing okay.
Oh, okay, I thought 700 was the true average. All right, okay,
No.
I'm understanding now.
You are trying to ask yourself, is this machine functioning properly?
Yes.
If it can produce 85% of 700, we will say it is functioning properly.
Okay.
So your test should be around 85% of 700.
Okay, and then the confidence interval at a 90, what was it? The 98
at 98%
is between, well, the mean is between 706 units,
607.
607 units and 671 units.
Precisely. So
Got it.
now, would you conclude that the machine is functioning properly?
Yes.
Because the lowest average that you can estimate that it does is 607, which is greater than 595.
Yes.
And therefore, you can conclude, you can use this confidence interval to say the machine is doing well.
Okay, got it. I understand.
You get the point?
Yes.
Okay. All right. The other thing that I wanted us to benefit from is there are sometimes somebody prints out the data for you. Okay. So we use SPSS. In the past, we used SPSS, but because we're not on campus, I'm not sure everybody can install SPSS on their laptops because we used to do this in the lab. And when you wanted to do your homework assignment, you will go to the lab because the lab has SPSS. So you get an SPSS printout that gives you a confidence interval. See that?
Yes.
And so it also gives you a calculated Z. So you can use this calculated Z to test a hypothesis. You can use the confidence interval also to test a hypothesis. You get it?
Mm-hmm.
It's already given to you. All right?
Got it.
The same problem, we went through it, and here it's giving you confidence intervals. These are illustrations. Okay? So some formula that you know, this is a table of the T distribution, but sometimes we just give you the information and you read it off, because I will. Okay? Just gives you the confidence interval, gives you the calculated T or Z, and you can do what you want with it.
Okay.
All right?
Yeah.
Okay. Do you have any other questions?
No.
All right. Thank you for coming. I'm glad that you were here. So you have benefited from asking questions and the clarification.
Yeah. Thank
I
you for
need somebody to be
clarifying
here
that.
every week before I give a lecture. If there's nobody here, then I think it would have any problems. Nevertheless, your presence is highly appreciated, because now I'm going to post this for everybody else to see. But the others did not have the benefit of asking clarifying questions, so they will have to read and view this PowerPoint slide over and over to clarify any point. All right?
Yeah.
Okay. So I'm glad that we did that. So have a nice evening.
Same. Enjoy. Good evening.
All right.